Jimmy, our intrepid engineer, has decided to take on a little home build project. Jimmy wants to be the new pumpkin Chunkin champion and launch himself, or rather a pumpkin, into the record books. Jimmy has decided to tackle the adult catapult class, where the world record is 2,862 feet. After a quick internet search for inspiration, Jimmy fires up SolidWorks and quickly creates his preliminary design. Now, Jimmy wants a winning catapult, but he can't afford the time and expense of building multiple physical prototypes. So before Jimmy spends too much time detailing his design, he decides to assess its capabilities with SolidWorks simulation. Put simply, how far can Jimmy's design launch a pumpkin, and is it strong enough? Jimmy turns to SolidWorks Motion to determine the maximum throwing capability of his catapult. Using the existing assembly mates and applying gravity together with a torsional spring, SolidWorks Motion uses real-world physics to accurately predict the pumpkin throw. The motion analysis of the catapult looks good, so Jimmy runs a non-linear dynamic analysis of the catapult to evaluate its strength and flexibility. Jimmy immediately finds a big problem. In an effort to save weight and cost, Jimmy has made the launch arm too flexible. His pumpkin would end up as an embarrassing pancake tens of feet in front of him rather than the thousands of feet that Jimmy was planning for. So Jimmy heads back to the drawing board. Now Jimmy could manually change his design and recalculate the motion analysis to achieve a maximum throw. But with SolidWorks, you can let the software do the grunt work for you using motion optimization. Jimmy sets up an optimization study that automatically alters the design parameters to maximize the pumpkin throw while satisfying both the competition's rules and the catapult's structural strength. After the motion optimization, Jimmy produces a second design with a much greater launch capacity. It's now time to rerun the nonlinear dynamic analysis to recalculate the catapult's stiffness, evaluate the component loads, and make sure that the structure can withstand the high-impact forces. Satisfied that his design will work, Jimmy can now begin to build his catapult. The catapult is strong enough, but how would the pumpkin fare? Not too well, it seems. SolidWorks simulation gives every designer the tools to evaluate their designs, giving performance feedback and allowing you to make critical design decisions with confidence. Test your next design with SolidWorks simulation to visualize how it will perform in the real world without having to build expensive and time-consuming prototypes, and maybe you too can create a world-class product. To find out more, contact your local SolidWorks reseller to see how easily you can attain meaningful results with SolidWorks simulation.